Hi guys, this is Shubham and welcome back to my second video. Today we will be discussing about what are large language models LLMs. You might have heard in recent news about ChatGPT, Google Bar, how AI will take your job, etc. etc. So today we will discuss about large language models, which are the basic building blocks, or I would say which are what we look at as ChatGPT or any other AI which processes natural language. So let's get started. So let's first break down what the name means. So let's get to what model is. So as you can see, it's a mathematical or computational representation of a system that can be used to make predictions or decisions based on input data. So you could have found this anywhere by Googling. Let's try to understand what this means in a simplified way. Model is basically an algorithm of a set of rules that your machine should follow to get the desired results. So if we don't look at it from the point of view of neural networks and this, if you have a problem to solve, like you have to go from point A to point B, you decide that okay, I will move in the direction which gets me closer to the place. If this was the rule that you follow to go from point A to point B, then it's a model. In case of LLMs or neural networks, so these are the complete system of neural network which has particular weights which will define what decision or what prediction the model will make. So the model, we can say, are a set of rules that helps our system to achieve the goal that it has been working for. Now, what is large and language? So, it's basically what we normally call large is humongous. Like, large is the size is big. So, in terms of both the system, like the number of weights, the size of the model, or large means humongous data. So, to train a LLM, you need large number of data to which is trained on it for it to do the prediction of words. So that's where large came from, and language is the natural language that we are speaking, or the LLM will predict or answer to you. So this was what the word meant. Now let's try to understand what are large language models. So on the upper surface, like you can think that large language models are basically neural networks which are trained on words, like the natural language, and the task of it is to reply to every question or the task you asked it to do. Now, what some of the features of large language models are: first of all, they are large, they have billions of weights, like 7 billion, 13 billion or more, to which defines what the model will reply to you. They are not restricted to a specific task. So earlier you could have seen the chatbots prepared by many companies, and the only task they could do was reply to few particular queries. So they were basically if and else statements. But these large language models are trained on such humongous amount of data that they can give reply to your questions irrespective of the field you have asked it about. So it is not restricted to just coding, but just science, just architecture, or it can give you answers about everything that the it is trained on. And the data on which it is trained consists of a variety of things. So it is trained on novels, it is trained on scientific literatures, it is trained on every piece of literature or natural language that you can find on internet. So even though they are not open source, like in my knowledge they have not been specifically told, like the companies like OpenAI and Google haven't told us like what was the exact data they used, but it is trained on a wide range of data. And just to give you an idea, so few models are trained on as big as 10 trillion number of words of data, and a person normally speaks about 8 800 million words in his whole lifetime of 70-80 years at an average. And similar to neural networks, the effectiveness of a large language model depends on how big it is, the data from which you have trained on it, and the computing power required. So you know that to train good big neural networks you require lot of computing power. Similarly, large language models depend on these parameters for its effectiveness. So this is the overview of what large language models are. Now let's try to understand how do they reply to your question. If you already have knowledge about neural networks, you would know that they are used for classification, prediction, recognition, which is also a part of classification. So, how do LLMs reply to your questions, which doesn't on a higher level look like classification or prediction? So let's understand that. So large language models basically predict the next word that will come after the input. So if there is a word, there is the input as today is a, the next prediction could be a good day, today is a bad day, or something like that. So as it is stated, it is able to predict what word might come next to it, next to the input. So if the input you give it is hi, the next words it might predict is I am. So this is how the base is built. On that, we do fine tuning of the model such that it's a question and answer kind of based behavior, that instead of, if you don't fine tune the model, so when you ask a question it may predict the next the next word as a follow up question to it instead of giving you an answer. As I have previously said, it is trained on as big as 10 trillion words of data, whereas a person hardly speaks about 850 million words in his whole lifetime. So as the example here shows, so if you give it the input as the student opened there, it may give you the prediction as books, laptops, exams, minds, anything. So this is after training the model, and when you give it do the fine tuning of it, it is converted into a question answer based approach. Now let's understand on what architecture are these neural networks based on. So these are based on an architecture called transformer architecture. So this was, if I'm not wrong, released by Google, and they are based on this. So why do you require transformer architecture? So transformer architecture self defines the importance of a particular word in the input. So you said, hi, how are you? I am Shubham. Then the transformer architecture will give the importance, like what my name is, or I greeted to it like hi, and would give less weightage to it, to words which doesn't matter much. So like if you have given it a long paragraph and then ask the model a question, it will give weightage automatically without you defining what is more important in that paragraph. So this is why transformer architecture is used in LLMs, which makes sense, as when you ask the chat GPT for some task, it is able to, most of the times it is able to get an understanding of what basically you are trying to ask, which can be said as it know what importance what importance it should give to a particular word in your input. Now, if you remember, the neural networks are basically signals. Like you give it inputs as numbers, and then it gives you numbers as output. But here you are transferring natural language and predicting the natural language. You are using words. How do neural network do that? So what we do is something called tokenization. In this, you convert the words and map them to a particular number. So it might be character wise, it might be word based, or it might be a club, a group of words, each defining one particular number. Like which and is, it can have two different number, or they can have a same number, which will help the architect, help the neural network to understand what reply to give. We won't go in depth into what tokenization is used by different products, but as you can see that just having a character wouldn't give much information to the neural network as having a word as one token, and the output is also a token, which is the prediction of the next word it should show up. Now, what is hallucinations? Hallucinations are basically the LLM giving you wrong information, or not or the information which doesn't make sense. So in case of Google's Bard, when the Google advertised its Bard to the world, it gave a wrong answer to the first telescope that was able to see, I think, the distance planet outside of Milky Way or something like that, and the answer was wrong, which costed Google $100 billion in its market cap as the shares fell. So the errors can be in any way, like it replies to you which doesn't make sense, or it replies to you about a fact which is wrong, like uh, India is a state. It might say that India is a state, like, and it will say, it wouldn't say that I don't know what India is. So these are kinds of hallucination that an LLM have. And but the question comes is why are there hallucinations? So, frankly, even the architectures who build the LLMs can't say, because, as you know, neural networks are basically black boxes, which does which which creates a model as you train the data on that and does the predictions. So you can't be pretty sure as why there are hallucinations, but we have some idea of what it might be. First of all, it's the data quality. So it depends on what data you use to train your model. So if you took the data from very bad resource, like you took it from a website where people write anything without factual checks, then the LLM will also hallucinate about those because it was trained on that data. And then there may be some generation methods which cause biases for a uh, particular replies, or a particular way it gives reply to the user. So we won't go deep into this, but you can look and study about these more if you're interested. And the input context. So if the person who is giving the input is not clearly explaining what he wants, then the issue will be with the input context, irrespective of if it is an LLM or a person. Even if the input is given to a normal person, he may not have a complete idea of what is the person trying to ask. Like if he says, like, if cow, does the cow talk? Does the cow talk? Cow is an animal and it doesn't talk. But if he is telling it with respect to some animation, with some cartoon, then it might talk in that cartoon. So the input context matters a lot. Now, how to minimize the hallucinations for LLMs? So it's basically you could do is you could provide clear input instructions to the LLM, which will help it to give you a proper result, and then putting some parameters accordingly. Some like there is a parameter called temperature, which defines how precise the result the response is to the input giver. And multi-shot prompting is basically whenever you give an input, it creates different prompts from that input and then gives it to the LLM to give a proper result. So to summarize all of this, LLMs are neural networks which are trained on tremendous amount of data, which and what it does, it predicts the next word after the input, the which helps us to provide answer to your questions. It is fine tuned so that there is a question answer type of prompt that you get, like when you ask a question, it gives you an answer instead of asking a different question. These large language models are based on transformers architecture because they can decide by themselves what importance the what importance should be given to a particular word in the input. It is also called self attention, but we won't go into the technicalities of that. And then we discussed about the hallucinations, like why it gives some wrong results or bad results when you ask few questions, and what all we can do to mitigate it. So that's all from my side. Just let me know what else we can discuss about, what are good topics we can create videos on, and I will try to do so. Thank you. Have a nice day. Bye bye.